So I think I'm going to start just for us not to run out of schedule. My name is Oz, I'm from Topology, and today I'm going to introduce you CRDT objects, which is a new construct that we've been doing in Topology, and how they can be used for peer-to-peer multiplayer applications. So, quick show of hands, who here is technical? People. Okay? That's not, it's fine, okay. And who here knows CRDT? Oh, okay, that's nice. Well, lots of people then. But what's some? So, CRDTs in a nutshell. CRDTs are based on this paper, which is one with pre-replicated data types. It's written by quite some people from Portugal, Paris, and that's it. And basically the TLDR is, yeah, I just update stuff on my side, and then somewhere in time, sometime, I'll just connect to other people to merge with them, and the thing that I wrote is going to be there, for sure. And the thing is, how this works, it's a bit trickier than it seems, because it's a bit of magic here, because the types that we are defining here are actually monotonic types, so they can only increase. In the sense that we have lots of examples for CRDTs. The easy ones are grow-only counters and positive negative counters, and the grow-only counter is counters that just grow in size. So if I'm incrementing my counter, I for sure know that my counter is always going to be the biggest value on the network. If someone might have a bigger value than me, and I'll discover that when I sync with them, but I know for sure that if someone has a counter that is smaller than mine, mine's value is the one that is going to persist. And the thing is, so we can have a global shared counter that I know that the value is never going to be smaller than the version that I have in my local machine. Positive negative counters enable you to do another construct that enables you to actually have a value that you are not sure if it's the maximum or the minimum, but you know for sure that the value of the positive negative counter is composed of two grow-only counters, and basically one is for positive values, the other one is for negative values. And the thing is, you know, for each one of those counters, the value is never going to be smaller. So, you know for sure the maximum value of those counters. These are the super simple examples and the most intuitive ones. Then we have also JSON CRDTs, which enables you with basic types to create some kind of object, and that enables you to have multiple use cases. And based on all of that, we did some small demo. This demo is Penguin World. It was done by some members from Topology. We have guilty videos that they're jumping around and showcasing the video. Here we built this basically with YGS, which is a super known JavaScript library for CRDTs. We also implemented cohesion here and all that. Although the cohesion here is super tricky, in the sense that it's not PFP at all. If I'm colliding with another person, I'm just saying, oh, back off, and the other person is, okay, I can back off, no worries. And the thing is, yeah, if you have malicious actors in the network, you can actually just say to another player to move to the other side of the map, and that player is going to move. So we started doing this, we tweeted about it, we had some good feedbacks about it, and we wanted to move on and do something else, because exactly because of those behaviors that we want to prevent for cohesions on the telekinesis and all that, we find that we needed to do another type of object, and that's where we started to build Topology protocol. And basically, Topology protocol introduces a new type of CRDT stuff, which is not CRDTs at all, it's CROs, which are conflict-free replicated objects, which is composable CRDTs. So we have the basic types for CRDTs, and you can compose them into objects. And those objects are also composable between themselves. And basically, CROs are really similar with Smalltalk. We are no Smalltalk. Not many people? Okay. Some people. Basically, Smalltalk is a programming language that is super old. Super old? Not super old. Quite some. And introduces some types of objects where we can have some signaling between objects there. We also have the blueprints. Like in CROs, we are intending on using the signaling to communicate between all the objects. We also have the interface to specify every type of function and signals that we expect to have there. And then we have functions. The functions, we have the mutators, which are going to change the state. The thing here is, of course, it needs to be monotonic to be compatible with the other CRDTs. And we also are going to use the view functions, where we are just reading state. The merge function is something that we always need in our case for synchronizing with other peers on the network. The thing about those functions is that we can abstract them totally for the VM that we are using. So we can do it in WASM, we can do it in JVM for Java, we can do it in almost anything. Currently in Topology we are focusing on building it with WASM because it's the most cross-compatible amongst all the places. But in the future it's supposed to be abstracted and you can just use whatever you want for it. This is more or less the things that we have within the topology protocol, not just the CROs themselves. And the thing is, we have the peer-to-peer messaging. We are currently using with P2P to do all the peer-to-peer messaging. Basically, we have point-to-point messaging there, but the most feature that we usually use is the hub subgrouping there. There are lots of stuff there that we don't have it implemented yet, but we are planning on implementing it soon. The causal consistency is one, TLC is the other, consensus is super related with the part on the top for snapshot and compaction, because otherwise we don't need consensus at all, because it's conflict free. We don't need consensus for that. But if we want to take snapshots, for example, for the state of the objects, we actually need to reach some consensus on, if you have an operation that depends on a super old operation, you can't. At this timeline, you can't have dependencies that are way before than that. And this is the super graph that Gigi drew in the back of his paper. And basically, this defines how PubSub works within the network. And the thing here that is super awesome is that so each core there represents one CRO, one type of object. And the thing is, when I'm propagating messages to other people, it's not like everyone on the network is going to listen to all the updates on every conflict-free replicated object. It's just the people that are interested in some CRO that are going to listen to those updates. And the awesome thing there is, so if I'm this guy here, I'm never going to listen to the updates on the boost side. And that's awesome actually, because if you think about it, it's just the peers that are connected to some application, and the application can be composed by multiple objects. But only if I'm connected to an application, I'm just listening to the updates of that application. I might be connected to multiple applications, I might have signaling to other objects, then I might want to keep a copy of those. But if not, I don't need to hear anything about those. And this enables lots of use cases. CRDTs are super used in the wild right now in the local first software, mainly on collaborative tools. So if you think about Google Docs, you have the big thing about doing a Google Docs where you go offline, you do all your changes, and when you come back online, you just merge all those changes. And the thing is, before, that there was another technology that was used for that, which is OT. But nowadays, people are mixing both. They are mixing OT and CRDTs to be able to do that is more performant than easily. Apart of that, we also have other use cases. You have social networks and applications. You can think about Farcaster. Farcaster uses a CRDT, a big one, to store all the posts and all that. And games and autonomous worlds is another big use case. So Topology background is heavily on the autonomous world, and most of the examples that we usually do is within those space. And for that we have a web demo. So the tricky part here, if you are on mobile, probably it's not going to work. So if you have your laptop there, you can just hop around and let's see if it works. Yesterday it worked. Yesterday we could make it. I'm also opening it here. Let's see if it works this time also. You already? It's counter-splash.topology.cg. And I need to change my keyboard. Oh, I already see keyboard jumping there.
Yeah, it's connected.
It's connected. But I need to change my keyboard.
It works on my phone.
You can see, but you don't have control.
Yeah, but I mean the messaging.
I can show you, but I fall. But I can show you the shortcut. Shortcut is you jump to the wall behind you, and then you go to the front. Okay. So this is skill issue totally. The thing is, the map that we have here and the volts are jumping. This is done everything with pub subgroups and messaging. The only thing that is CRO, that is an object, is at campus there at the end. And the thing is, because of him, it's too hard to go to the front to draw. But actually, we can go there and draw. If I'm not too lagging, I can try to go in a sec. Let's see if the skill issue is not that big. And we also have lots of seekers, awesome seekers. So I can actually, I'm going to select here my dog. It's this one. This is Utah. And we have Utah here. And in theory, everyone that is connected, they can see Utah on their campus. And this is a big CRO.
Let's wait until one of the audience can put a sticker on.
No. Then we are going to spend here lots of time. So you can still jump around there. It's all about them. If you don't see Utah and you are connected, please let me know, because that might be troublesome. But you can just hop around there, and I'm just coming back to the presentation. So, and this was the backup plan. If it didn't work in the end, we have people in the front already painting stuff, and I'm going there to paint also some stuff. So the thing here is, why do we need the backup plan? In theory, this was supposed to work out of the box, and we don't need backup plans. Everyone knows that live demos always work. The thing is, it worked. So we are super good, and because of internet allowed us to do it. Nice. The thing is, if in fact we had failure here, it was mainly because of those two big issues. And those big issues is most of the networks, so we are doing everything with WebRTC, and browsers are connecting with each other. We are not relying with any server. We have one server, but that server is only facilitating us to exchange the SCP, which is the session file for us to connect with WebRTC. And the thing is, firewall, yeah.
So is that canvas at the back stateful? Like, if you load it up again, will your dog still be on there?
That's a nice question, because that's the part where most of the time we need snapshots. Because if everyone goes out and then comes back, yeah, if everyone goes on the states for this, not persistent.
Yeah.
And that's why we need snapshots also to be able to have some place where we can put the state when everyone is leaving, and when we are coming back to that exact same thing that we want to go, we need to reiterate the state. Yeah, but currently we don't have anything like that. Yeah. Failures. Firewalls and not traversal are problems in peer-to-peer. That's something that it still exists. With P2P, and the guys from Protocol Labs have been doing a great job there. But this is still a big problem that we have with browsers. Without browsers, Quick already helps you to bypass most of those problems. And we could also use relay servers to help out here, but the thing is, the amount of data that we are passing is too big. It's too big in the sense that it's a lot of information, and relay servers are not known for being super efficient. And because of that, the relay servers actually might be a bottleneck there. But these issues are actually fixable in some sense if we have actually a node within that group of interest that is public. That's totally public. Because this only happens if we have a browser connection where I'm behind lots of firewalls and NATs and all that. But if I have a public node that is accessible to everyone, is within the pub subgroup, is just going to relay all the messages to everyone. More than one maybe. One might be triggered. But yeah, so in Topology we are solving lots of our problems. Most of the problems that we have here, we already have some small solutions that might work, not efficient at all. And we need lots of research on most of the problems. These ones are the main ones that we've been thinking and talking about, which is constraints in CRDTs. This is super important for BFT behavior. So when you're talking about telekinesis, movement, I'm teleporting from here to there, most of those are fixable with constraints within CRDTs. And I think that is a super open problem that is being researched currently in universities. We also have DDoS because, yeah, I can just spawn up a new peer, and who knows, I'm just connected to the network. I'm a new person. If I do bad behavior, I'll get blacklisted, but then I create a new peer. So I'm DDoSing the network. We have time. As the concept of distributed systems, it's always a tricky thing. Compaction, hash graph, and since we are working in lots of difficult problems, we are actually also hiring. So if you find that those problems are super interesting, you can just reach out to us. We are more than happy to connect with anyone that might be interested on it. And if you are here just for the vibes, we also have lots of social media and websites, Telegram, Discord. Telegram was created yesterday. So, but we also have Discord. Discord link is a bit tricky, so I put the QR code here. And we also have our GitHub. Our GitHub has, so most of the things that we have been doing is totally open source. So all the papers, all the specs, all the code that we've been doing is totally available on GitHub. The specs are not fully completed, and the paper is going to have a big review within the next week. So you can just join the communication channels, and we update you whenever we have everything updated. And that's mostly it. I'm open for questions now.
How should I think about the size of the snapshots? Is it just the same way that I would think about a Postgres database, or is there some kind of additional size?
So the snapshots, the only thing that we want to, so we want to have blueprints somewhere stored in somewhere that is saying, oh, okay, so the blueprint for this object is this, and that's fixed size. We don't need to care about that. The snapshot that we want a part of that is the state snapshot. The thing is, one of the problems that we are aiming on solving is the compaction thing. And when you have compaction, you can actually cut lots of historical parts of the state, and you can just store some part of the history and the latest state that you have. So the goal here is for you to not have super big states. Just because of the compaction. Otherwise, we would need to store the latest state and the old history. And if we did that, then we would require lots of storage for the states. But the answer for your question is more like, it depends on the size of the object. If we have a super big object, of course, even the most current state is going to be super big.
What's the right way to think about consensus? Like, I don't understand how consensus works between these. Like, you must have some very strong requirements where you can make it really. You can probably very modular.
The thing here is most of the things so consensus we only need it when we are talking about compaction. Before that, we don't need consensus at all, because this works everything based on CRDTs, and basically those data types enable you to you have ways of fixing conflicts that are predefined. So when we both have a conflict, we know for sure who's going to get the conflict, how the conflict is going to be fixed. And that's why you don't need consensus. Everything that you are doing within the object is going to be event consistent.
So it's not dependent on majority, minority ideas, it's more about rules that we can predefine.
It's predefined rules, yeah.
Okay.
So and the thing for consensus that we totally plan on is just to define what point in time we are saying, okay, at this point in time we are not going to accept all dependencies here. Anyone needs to have the latest dependencies on the operations for putting some new operation here. Yes. What else?
Yeah, what's the dream?
The dream of this is you just rebuild the whole universe with CROs.
Do what, sorry?
All universe. All the atoms are going to be CROs.
Oh, okay.
Imagine a speakeasy space
Yeah,
that instantiates out of nowhere.
Yeah.
It doesn't have any central coordination circuit really well. Maybe you have one coordination circuit.
Are there any use cases like someone actually using this for a real world, like it solves something?
Currently, CROs are not used anywhere. We are developing the protocol now. But CRDTs are used in lots of places. You have databases. Databases use CRDTs. You have Farcaster as an example that is super big now. They are getting some scaling issues right now, which is normal with the sudden scale that they had. But CRDTs and the cooperative tools it's a big space that lots of people are using CRDTs nowadays. Yeah. You also have the canvas. TL Draw.
Yeah.
TL Draw. TL Draw, for example, is a super nice project where they are using CRDTs and You can just draw stuff, and it's basically a CRDT, and everyone can see the updates and all that. It's also considering a collaborative tool. You even can think about Canva or Figma. You can, when people are hopping around there to your shared presentation, people can just start drawing on top of it, and it's going to be, all the conflicts that you might have there are going to be fixed in a predetermined way. Thank you.
Thanks so much, Rogue. We have actually now a 15-minute break, and afterwards we have